Good morning. Today we are working on inverse relations. And as we're talking about inverses, you might have heard the word inverse before. Inverse usually means opposite. Sometimes we use it to talk about inverse operations, where like we have addition and subtraction are inverse operations. And that's going to help us that notion of opposite today. So the inverse of a relation is the interchange of the x and y variable. The interchange of x and y. In a graphical sense, what that means is if we're changing x for y, we're really reflecting it over y equals x. We're reflecting it over here. So if we had a point over here, it would end up over here. If we had a point right here, it would end up over here. If we had a point on the line, it would end up on the line, right? So we're thinking about how we can reflect it over, this is y equals x. So the inverse of a relation is written as r prime, like this, with a little like apostrophe kind of thing. That's the notation. So when we give if this is our example, it says give the inverse of relation r below. They tell us what the relations are, so they're telling us individual points. You see 4 points there, and they want us to find r prime, or the inverse. So you know what? I totally messed up. This should be r -1, like that. We don't really say to the power of -1. That's not really what it means. It just means the inverse of r, right? So we read this as the inverse of r, like that. So when we are finding the inverse of r, we want to switch x and y every time we see it. So if this is our current x and our current y, then when we're finding the inverse, we're going to flip it. So it's going to be 2, 0, right? 2, 0. So same thing with this one here. 3, 4 is turning into 4, 3. These are switching to become -2, -3. And 2, 4 turns into 4, 2, like that. So those are our new points. If you can imagine like the xy plane, 0, 2 would be here. And if we were to reflect that, 2, 0 would be over here. 4, 3 would be like up here somewhere. And 3, 4 would be like right here. So you can see that they're reflecting over that xy line. So that's how we would do it with points. We can also do it with equations and with graphs. So with equations and graphs, we're going to still switch x and y. So first, in order to have x and y to switch, we need to replace f of x with y. So I'm going to say, okay, this is y equals x minus 3 squared minus 2. That's the first step. The second step is to change x and y, right? So I'm going to change this into x and this into y. If there were multiple x's or multiple y's, you would change both of them. You would change all of them to whatever the opposite is. So that's my second step. And now we're going to solve for y. So I want to get y by itself here. I'm going to work with the things that are far away first. So I would have x plus 2 equals y minus 3 squared. I'm going to go ahead and take the square root of both sides. So now I have the square root of x plus 2 equals y minus 3. And then I'm going to go ahead and add 3 on this side. So we have x plus 2, square root of x plus 2, plus 3. This would be my inverse, right? So because I've switched x and y, this is now the inverse. And so that was solving for y. And now I want to rewrite y as the inverse notation, which looks like this. So I'm going to say f, the inverse of f of x is equal to the square root of x plus 2 plus 3. As you get to more higher levels of mathematics, you'll find out that there are some domain restrictions and things because this is a parabola. If you think about this, right, here's a parabola like this. And when we turn it on its side, it's now going to look like this, right, which is no longer a function, right? So technically, this function doesn't exist. So it would be, we could say this is not a function. right? So we'll dive into that a little bit more later. For right now, I just want to get us to this idea of interchanging X and Y. Okay. The same is true for our graph. Right, same is true for our graph. So we're going to mark the points. I see a point here, a point here, a point here, a point here. I might put them in a quick XY table. So I have -1, 5, -3, 3, -4, 1/2 maybe, and -5, -3. Right, so that's how I'm going to mark my points. And then I'm going to go ahead and interchange X and Y. So I'm now going to have 5, -1, 3, -3, 1/2, -4, and -3, -3, -5. I'm going to go ahead and graph those. Right, so that was my second step. I'm going to go ahead and plot the new points. So 5, -1, wow, done. 5, -1 would be right here. 3, -3 would be here. 1/2, -4 would be like right about here. And -3, -5 would be right about here. So I can see that it creates that nice little shape that we see up top, right? And we can see that that is reflecting over this line. And what I mean by reflecting, if I took that top graph and I flipped it over that green line, it would make the purple graph, right? So it's reflecting over that line. That is how we would do it with our graphs. All right. And then finally, we have the idea of one-to-one functions. So in the past, we've known the word function and we've thought about the vertical line test, right? The vertical line test, you draw a line like this, vertical lines all the way across. It's not allowed to touch twice. That tells you if it's a function. The horizontal line, or the horizontal test, if you went this way, we used to tell you it didn't really exist, but it does. It means that you're going like horizontally, you're counting it, and that would tell you if your inverse is a function. In order to be one-to-one, both the function and the inverse of your function need to pass the vertical line test or the horizontal line test. So both need to be functions in order to make that happen. So vertical line test, I'm going to go ahead and test it. This is looking pretty good. This part looks a little scary, but I know that that line is it's increasing and moving ever so slightly along the x-axis. So this does indeed pass. And then I'm going to go ahead and check my horizontal line test. And I see that there's no place where it crosses. So yes, indeed, it does. And so therefore, this is one-to-one. So one-to-one function, okay? And then the vertical line test for this one, let me go ahead and try this. It does pass. So yes, this is a function. But check out this horizontal line test. If I cut a line right here, it's going to hit in multiple places. So it does not pass. Therefore, it is a function, right? It's a function because it passes the vertical line test, but not one-to-one because it does not pass the horizontal line test. 1, 2, wow. 1, 2. That's just sort of like a definition that we're learning today. Okay. Well, let me know if you have any questions, guys.